Hi, I'm Katia Chavez. I work here at the Natural and Social Science Lab at the Miami-Dade College Kendall campus. Today we're going to see two basic concepts in chemistry that you need to master: atomic weight and formula weight. However, before we go into that, we need to know what AMU is. Just as in our daily lives we use pounds, grams, kilograms to record mass, we need to know that in chemistry, the unit that we use is AMU. Okay? So AMU stands for atomic mass unit. And as the name says it, it is a mass that we need to find out for one atom only. Now, it is a very small unit. Imagine that it's in the order of 10 to the negative 27 pounds. So imagine, it's very, very small. 1 grain of sand would be much heavier than 1 AMU. Now that we know this, we can know what atomic weight is. Atomic weight is the weight of one atom expressed in AMU units. So, let's imagine about lithium. 1 atom of lithium. If we go to our periodic table, we will see that lithium has a mass of 6.941, right? So 1 atom of lithium will weigh 6.941 AMU, because that's the unit that we use every time we refer to atoms. Now, what is molecular weight? Well, there are 3 things that I need to know. First, the molecular weight by definition is the weight of one molecule. In this case, let's suppose it's water. First, to calculate this molecular weight, I need to know what atoms are here. I have hydrogen and I have oxygen, right? Second, I need to know how many of these atoms are in this formula. And I have 2 hydrogens and 1 oxygen. Correct? Third step, I have to write down the atomic weight of each of these atoms. So the atomic weight of hydrogen is going to be 1.00794. But for our problem, we are just going to use 1. So it's 1 AMU. And the atomic weight of oxygen, if we look at the table, it's going to be 15.9994. But for this problem, we're just going to round it to 16. So the atomic weight of oxygen is going to be 16 AMU. Finally, what we need to do is think about this. We have 2 hydrogen atoms, and 1 hydrogen atom contributes with 1 AMU. So if we multiply 2 times 1 AMU, I will get the mass contributed by 2 hydrogen atoms, and that will be 2 AMU. If I have 1 oxygen atom and this contributes with 16 AMU, when multiplying them, I will have 16 AMU. And thus, that is the mass that is contributed by each of these atoms. So the total has to be the addition of these 2, right? So the total has to be 2 AMU plus 16 AMU, which is 18 AMU. And this is the molecular weight of water, but 1 molecule of water. Now, finally, formula weight. Formula weight is the weight of 1 formula unit. And what is 1 formula unit, you may think? It's very similar to the molecular weight, It's just that the molecular weight refers to covalent compounds. And the formula weight refers to ionic compounds. Which are also referred to as formula units in this case. The methodology that you will use to get this answer is the same that we have seen before. So now you have all the skills that you need in order to resolve any problem involving mass of atoms or molecules. So stay tuned.